Okay, so we'll get started in a couple minutes. Make sure to fill out the poll in the meantime. We'll probably get started around 1:05. Okay, we'll go ahead and get started. Okay. Hi everyone, welcome to week 4 of Python programming. So again, this is our course overview. We started off with print statements, variables, and data types. Then we went over lists, slicing, tuples, and then last week we did for loops, if loops, while loops, and functions. And then today we're going to go over string methods and modules. So this is today's agenda. We're going to first go over the examples that we didn't get to last week, and then homework answers from last week's homework. And then we'll do some review. And then our topics are more on functions, accessing characters and strings, string methods, random, math, and other modules. And then we'll do some practice problems again. And then we have homework again for this week. Okay, so these were the practice problems from last week. Let me minimize my screen and I'll split it. Okay, so our first problem was translate the following for loop to a while loop so that the program does exactly the same thing. Hint, you need to initialize a variable before, change the for loop, and update the variable outside the if loop. So the reason why I gave you guys a hint is so that we don't have any forever while loops or while loops that never stop or never terminate. So for this question, let's just write out the for loop that's given to us. So it's saying for num in range 2, 20, 30. So that means from 2 to 20, not including 20, with a step of 3. If num is, if the remainder when dividing by 2 for num is equal to 0, oops. No. So if we run this, we get 2, 8, and 14. So in this case, we have to first initialize a variable before, and that variable is our num variable again. So we're going to say num is equal to, and the starting variable in this case is 2 since the range starts at 2. So we'll just say num is equal to 2. And then our while loop, we have to say it has to keep going until a certain condition is met. So in this case, the for loop keeps going until it reaches the number 20, and then it terminates. So our while loop would look like this. While num is less than 20, if num when divided by 2 has a remainder of 0, and then now update the variable outside the if loop. So now we just do num plus is equal to 3, since our step in this for loop was 3. So let's run this. So yeah, we have 2, 8, 14 again. Does that make sense to everyone? Okay, so this is number, oops, number 1. Number 2. Okay, so write a function is odd that returns true when n is odd and false otherwise. Use these tests for your function. Okay, so we have the function name given to us is odd. So remember, we defined functions by using the def keyword. So you'd say def, and then our function is odd. And then the parameter in this case will be n, because we want to check each time we call that function if this specific number or n is odd or not. So n is going to be our parameter. And then how we would check if a number is odd is just by doing an if statement. So you can say if n when divided by 2 has a remainder of 1, that means that it's an odd number. So we would return true. I'm not sure if we went over return statements, but this is basically whenever you call a function, it'll return either true or false. And then that return is now defined as that function call. So let's finish writing this and then I'll explain it. So else it would just be return false, since when we divide by 2 and it's equal to 0, which is the only other case, it would be even. So now when we say, now we would have to define is odd to a variable, and we can print out that variable, or we can just print out whatever is odd returns. So in this case, let's say we want to check if 2 is odd. Then we can say 2 is equal to is odd, and then print 2. And then another way we can do this is just by saying print is odd 2984. So both of them are even, so it's false. Does that make sense? So when you return something to inside of a function, you're not printing it to the console. Instead, you're storing it inside of that function call, if that makes sense. So we can try other things, like we can try print is odd very huge number. And that's true. Last but not least, number 3. Write a function print winner of winner with parameter winner that takes the integer winner and prints out the message according to who won. So again, this is just a function with an if loop inside. So we define our function print winner. And then our parameter is winner, which in this case is an integer. And then we say if winner is equal to 1, then print or if winner is equal to 0, or if winner is equal to -1, print. And the last statement is else. Unknown. So the reason why we have this, the reason why this last else statement is useful, and it's not necessarily used in this function, is because sometimes winner can be a different data type, or it can be something that's not in any of the conditions in the if statement. So we need an else statement to say, okay, if it doesn't fit any of these conditions, then print out unknown or wrong data type or something like that, to let the user know that whatever variable you're inputting as a parameter to the function is not being taken in correctly because it's a wrong data type, or it's not the right value. So now that we have our function, we can do a test case. So let's say print and it should print out I1. Yeah, so it prints out I1. You can try print. Let's say 0.5. Then it prints out unknown. So does that make sense to everybody? If you have any questions, just tell me in the chat or unmute. Anything works. Okay. So let's move on to homework answers from last week. Okay. So all of you should have completed your homework from last week. This was on mostly, oh, is this the right one? Yeah, so it's mostly on for loops, if loops, while loops, but there's also stuff on like data types and strings and other things that we did. So let's go ahead and open this REPL. Let's copy paste. So for this one, as I'm doing the sorry, give me 1 second. Okay, so as I'm doing the as I'm going over the answers, make sure to put in the chat what you guys got, or if you have any questions at all. Okay, so first question, comment out the variables that have an integer value. So for this one, put into the chat what you guys got. Remember, commenting out is just using this hashtag before a line in order to make it a comment. So put into the chat which variables you think are integers. Okay, so let's go over what integers are. So remember, integers are just numbers without any decimal. So in this case, or like whole numbers. So in this case, 24 is our integer. And then 1 second. Okay, so while I'm fixing this problem, put into the chat what you think the variables are, and then I'll come back. Okay. No one, okay. So first one is 24. 15 divided by 7, that's not evenly divisible, so that's going to be a decimal. So in this case, it would be a float, so that's not an integer. 27 divided by 3, would that be an integer? I'm not sure. Let's just say it's an integer for now, and then we'll check with the print statement. And then variable 5, this one is an integer because we're getting the the floating point division. So in this case, this one would be an integer because it rounds to the nearest integer that when you divide it. And then this one, 59, the remainder when divided by 5 is also going to be an integer because it always returns the remainder, which is always a whole number. Oops. And then variable number 7, that's an input. So that's going to be in data point, a data type of string. So that's not an integer. 1 plus 5.0 is an integer. And we'll check this with the print statement again, just to see. And then variable 9, int of input, enter an integer number. That is also an integer. Oh, let me comment that out. Okay, enter an integer number. So this is for this input statement. So 9.0, 6.0. So in this case, 27 divided by 3, it's giving us a floating point division, even though it's evenly divided. So we need to remember whenever we have this division symbol, it's always going to give us a decimal or a float as a result. So in this case, this is not an integer. And then 1 plus 5.0, that's not an integer because we're adding an integer and then a floating point. So it's gonna give us an answer that is a floating point. So this is not an integer. So this looks correct. var2 is an integer 24, var5 37, when rounded when divided by 5, and then 59, the remainder when divided by 5, and then converting this input into an integer, which okay, so this is the next part. So number 2, modify the following program so that it will convert degrees Fahrenheit to degrees Celsius. Change the degree C assignment to F to C. Okay, so you were given this formula to convert F to C, which is just degrees Fahrenheit minus 32 times 5 divided by 9. So in this case, degrees Celsius, we would have to fix this. So it would be degrees underscore Fahrenheit, which is our parameter here, minus 32 times 5 divided by 9. And then we would return degree C back to the user, and then we have an input statement. What is degrees in Fahrenheit? And then we would print out the degrees in Fahrenheit to degrees Celsius. Okay, let me count this out. What is the temperature in degrees Fahrenheit? Let's say 32. So 32 degrees Fahrenheit is 0.0 degrees Celsius. You could check other values. 676, 24.4446 degrees Celsius. Okay, hopefully that makes sense. Okay, next problem. This program calculates how far an object will fall in feet in a given number of seconds. However, it does not produce the correct answer. Find and fix the error. Can't think of data types for this problem. So we have G here, it's a floating point, 32.174. We have T here as an input, enter the number of seconds. And we say D is equal to 1 rounded when divided by 2 times G times 2 to the power of 2. So remember, 2 asterisks means to the power of, or exponent. Print the big fell, and if we run this, enter the number of seconds, so let's say 10 seconds, we get this error. Unsupported operand types for power, string, and int. So basically, this is telling us that these two values are different data types. So we can't do anything in this expression. So we would have to change one of these data types in order to make this expression valid. So in this case, our input right now is a string, since input is always a string unless we convert that data type. So we would have to say float, enter the number of seconds, or int in this case. Int works too. So if we enter 10 seconds, the brick fell 0 feet in 10 seconds. Let's say 100 seconds. The brick fell 0 feet. That's weird. Okay, well, hold on. Let's try this again. Let's say 720. Okay, so the brick fell this number of feet in 720 seconds. So this is actually supposed to be just dividing by 2, not integer division. Okay, next problem, number 4. Write a program using a for loop that adds up all the even integers from 2 to 10 inclusive and prints out the result. Initial code has been given. What does the job? Without a loop, but the code is very repetitive, so change the 5 repetitive lines of code with 2 lines of code to add up the even integers. Use even numbers, the loop variable in the for loop. You must also use the range function to generate even integers from 2 to 10. So right now we have these like 5 lines of code, and it seems really repetitive, and we could just use a for loop that would make it easier. So we have sum is equal to 0. And we want to write a for loop. So here we're given use even num as a loop variable for the for loop. So we would say for even num in range, because we need to use the range function, generate even numbers from 2 to 10. 2 to 10, and then they're even. So we have to do a step, or it would be 11 because 10 has to be included. And it would be a step of 2 so that we get every even integer. And then we would say sum is equal to sum plus even num. So now if we run this, 2, 6, 12, 20, 30. Does that make sense? So I can copy and paste this again and see. So this 30 should be the same as this print statement. So the last print statement should be the same. So 30, and in this case, since sum was the same variable, it's supposed to be 30. Hold on. Yeah, so 30 and 30. Same thing. Okay, number 5. This one was our coins function. So this one is quite long, and I don't really have time to explain it because we need to get to the slides. So I'll just go ahead and copy paste this, and then I'll put it in the slides as well if you guys want it. So this is number 5. Basically, we just write a function that when you give it the number of cents, it would give you the number of quarters, dimes, nickels, and pennies that you would owe. So this is just the code for that. And then I'll put it, I can put it in the chat, but it might not be that helpful. So yeah, let's switch over to the slides now. Okay, so this is review from last week. Again, we didn't really go over input last week or statements, but we'll just refresh that. Input is when you have a variable name and the object stored inside of that variable is the user's input. And the string, it's always a string, and the string inside the print of the input statement is printed to the console, and then whatever the user inputs afterwards would be stored in the variable. There's also format functions for print statements and the return statement. For for loops, you iterate through lists or using the range function in order to do some sort of action. We have an example here. If loops, we have the if loop, if else loop, and if else loop. While loops, they execute a number of times before terminating or until a condition is met, and they can replace any for loop. Defining functions, we have the built-in functions that we've used before for like strings and stuff. But then we also have user-defined functions when we can create our own functions, which has reusable code in order to do some sort of action. And after we define it, we can call that function. Alicia, you want to go ahead?
Yeah, okay, so now we'll be going over more on functions. So first we'll talk about like the basic parts of a function. So there are 2 main parts in the function definition: the function head and the definition head and the definition body. So the definition head has 3 parts: the keyword def, an identifier or the name of the function, and the parameters held in the parentheses. So in the examples shown, it starts with the definition head that starts with the keyword def, and then the identifier is add 2 nums, and then the parameters num1 and num2 are within parentheses, and the definition head ends with a colon. The function body or the definition body starts after the colon. So the statements within the body are indented, showing that they are part of the function. And the body ends with the return statement to get a specific value from the function. In the example, there are comments describing what the function does, which is followed by the statements that complete the task of the function, and which is adding 2 numbers. So sum is equal to num1 plus num2. And notice that num1 and num2 are the were the parameters declared in the definition head. And then these statements are indented, and the function ends with the return statement, returning the sum value. So more on strings. So like we said, strings are a sequence of characters which can contain anything inside. They are enclosed by quotes and are immutable, which means that they can be changed. So there are two operations that you can use on strings. Concatenation, which is basically means adding strings together using the addition operation, and multiplication of a string. So basically it's just like the examples shown on the slide. So it's pretty straightforward. And then you can also use the len method to find the length or number of characters in a string. And strings can be compared like numbers, as every character has a specific value associated with it according to the ASCII table. So an example of the ASCII table is shown on the slide. So to access characters in a string, to access a single character, you would specify the string name followed by a number in square brackets or the index. So this is basically similar to how we access items in a list. The index is the position of the character in a string with the first index starting at 0. You can also access the string backwards using negative values with the last character having an index of -1. To access multiple characters, you would use slicing, similar to slicing a list. Like this, so what you would do would you would specify the start index and end index separated by a colon and return, which would return a part of the string. But note that the end index is not included in the output, similar to how it works with the list. To reverse a string, you would specify the string name followed by 2 colons, indicating that we want to go backwards, and a -1 to indicate the step in square brackets. And then we can also use modules to access specific things that are outside of what the Python, like its default library already has. So essentially a module is a library of Python code used to add additional functionality. So the syntax would be starts with the import keyword followed by the module name. The math module, like one example is the math module, and which provides access to many mathematical functions and numbers like pi, square root, and many others. You can see like an example on the screen. And the random module generates random numbers based on specific parameters. So random has different, like, I guess, methods. So there's the random method, there's rand range method, there's rand int method, and those basically they're similar, but they have different parameters. And then string methods. So basically strings have methods. They can call these methods since it isn't a string is an object, which will make this object do something. So two like common examples of string methods are the capitalization methods and the white space methods. There are 3 capitalization methods: the upper method, lower method, and capitalized method. The upper method will return a string in all uppercase. The lower method will return a string in all lowercase. And the capitalized method will return a string with the first character capitalized and the rest lowercase. But you have to note that the original string will not be changed. Instead, a modified string will be returned. There are also white space methods, which remove the white space within a string. The outstrip method returns a string with the leading white space removed, which is essentially the white space before the sequence of characters in a string. And the rstrip method returns a string with a trailing white space removed, which is the white space after the sequence of characters. And the strip method returns a string with leading and trailing white space removed.
Okay, so now we're gonna we're gonna do a quick demo and then we'll do some practice problems after that. Okay. So let me create a new REPL. Okay. So we're going to be going over some more things on functions, accessing characters and strings, string methods, random math, and more modules. So let's do a quick problem. So let's say we want to create a function called my function that prints out hello, first name, last name, when given first name and last name as parameters. Make sure to test your function using one or more cases. So first, you guys try this on your own, and then after like 5 minutes, we'll touch back in and then we'll see what you guys got. So we want to create a function again called my function. We want to print out hello and then first name, last name, given first name, last name as parameters, and use any test case that you want. And once you're done, just say that you're like done in the chat. Okay, so this one should be fairly simple. I'll go ahead and go over it. If you still didn't get it, that's fine. So we want to define a function. So we would say def my function. And we have two parameters, first name and last name. And we want to print this print statement. Hello, first name, last name. So for this, there's two ways that we can do this print statement. We can either like add strings together with the parameters. So like we can say, oops. Space plus first name plus space plus last name and plus period. Or we can use the format function that we touched on last week. So this is where we would just say hello, first name, last name. And instead of these parentheses, we would put curly brackets. We don't need these variables either. So wherever these curly brackets are, this format function is going to fill in whatever variables you put inside in those corresponding curly brackets. So in this case, we have first name and last name. And it'll do it consecutively. So either one of these methods work. I'll just comment out one. And then we can do some random test case. So my first name is Sanjana. So if we run this, it says hello Sanjana. Does that make sense? Okay, next we'll move on to accessing characters in a string. So we have a string called hello world. And if we remember from when we did slicing, we want to get a specific substring of this original string and assign it to another variable or do something with it. So in this case, we want to assign hello to another string. So we would say string in brackets 0 to 5. So this is 0, E is 1, L is 2, L is 3, 0, or O is 4. So since 4 has to be included, we would have to say from 0 to 5. Because this is start to end plus 1. There's also, we could just say, instead of doing 0 to 5, we can just say colon of 5. Because the default value, if it's not specified, is going to be 0, or the first element, or the first character in the string. And then we can print. So we got hello. Next, let's say we have this phone number, which is a string in this case. Our phone number 123 556 7890. So we have this phone number, which is associated to my name, and we want to access the last 4 digits of that phone number and assign it to any variable. So last 4 is what we can call it. Last 4 digits. And then how we do that again is by slicing. So there's 2 ways we can do this again. And I'm not talking about these 2, like this and this, because in this case, we couldn't use, or we could use the default value at the end. So let's count these indexes. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So our last index is 22. So we would want to get, this is 22, this is 21, this is 20, this is 19. So we want to get from 19 to the end. So we would just say 19 colon, and then the default value after that colon is just whatever that last index is of that string, which in this case is 22, or it'd be 23. Another way we can say this is by doing -4. So if we remember from last week, if we wanted to go backwards in the string, we would have to use -1. So in this case, if we just say -4, it's the same thing. We want to go backwards by 4. And then we can print last 4. So we have 7, 8, 9, 0. Does that make sense? Okay. So next, string methods. So we have this string called myString, and it has an insane version of happy birthday. And we want to print it differently. So let's say we want to print this string with all uppercase letters. We would use a certain method, which is called upper. So this would just convert my string, and every single character, which is a letter, would be converted from a lowercase to an uppercase. If it's an uppercase, it would just leave it alone. And we can also do lowercase, so same thing, would just be dot lower. And then we have this white space here. That, let's say we want to get rid of this white space in between the quotations. We can say print my string dot L string. And that basically gets rid of the white space before this first character, L strip, left strip. And so remember, when we use these methods, the original object, so my string, is never changed. It's only giving you a copy of that string, if that makes sense. So let's run this. So we have happy birthday in all caps, happy birthday in all lowercase, and then happy birthday without the spaces at the beginning. And then we can check what my string is to make sure that it didn't change the original string. So here we have the original string. Okay. So next, random modules. So random and math is the modules that we're going to be focusing on today. And for our project as well, which is going to be coming up next week or the week after, I think. There are so many other modules or libraries that you could use that you can definitely look for online. If you just do like a quick search, there's like thousands of libraries that you could use for your programs. So let's just use random right now. So let's import random. And so random can do a lot of things. There's the random function. We can print, if we want to print a random number from 0 to 1, we can use the random function. And this just defaults to a range of numbers from 0.0 to 1.0. So this is not an integer. It's not going to give you an integer. It'll give you a floating point. And 0.1 or 1.0 not included. So if we print this, yeah, so we have this random decimal. There's also rand int in case we want a random integer, not a floating point. This we would say dot rand int. Let's say from 10 to 20. If we run this, it'll give us a random integer. 12, 14, 15, 12, 17, 17. Also rand range, and this kind of works like the range function that we use in cases of like for loops and stuff like that. This is when you want a random number from like a specific range, or you want it through like with a step. So like we can say a step of 2. So 10 through 20 again, but with a step of 2. So it'll always be an even number. Okay. And so random.random, this is the most basic function of the random module. And mostly all functions in the random module depend on this random function. So they all branch off of this random function. But you don't really need to get into that. That's just extra information. So let's go into math, the math module. So for the math module, there's so many different things that we can do. We have pi, e, square root, so many things. So let's say we have this problem where we want to define a function that returns the area of a circle given the radius. And we know the area of a circle is pi times r squared. So we can define a function area of circle with the given parameter of radius. can say area is equal to pi, whatever pi is, times radius to the power of 2. So in this case, we don't want to type out like 3.14159. Oops, that's wrong. 3.14159, whatever, because pi is never ending. We'll never end our program if we type that out. So we can use math.pi to just give us that exact pi value. And then we can return area and then test this. So area of a circle with radius 5. So this should print out 78.54, about 78.54. So if we run this, yeah, 78.5398, whatever. And then there's other math functions like math.e. There's also square root, where if you want to get the square root of something, you just put it into this square root function. Okay, so let's do the practice problems. Go back to the practice problems. So do these practice problems for around 5 minutes. Again, I won't go over the answers today because I don't think we have enough time. So we'll go over them next week. But once you're done with the practice problems, put your answers into the chat of what you got. So spend like probably like 7-8 minutes doing this. Okay, so I think a couple people finished, which is good. So yeah, make sure to, if you didn't finish the practice problems, do them along with the homework, which let me unpause. Yeah, so this is the link for our homework next week, for this week. Make sure to have it ready by next week, and then we'll go over it at the beginning of class again. And yeah, this document here, which I'll send to the chat, has all of the resources or announcements for this class. And it has previous week's homework problems as well. Thank you guys for coming today and have a great week. Okay, so again, it's 2 o'clock. We'll wait for like 5 more minutes, see if more people come in, and then we'll get started. Okay, so it's 2:05, so we'll go ahead and get started. Welcome to week 4 of machine learning. We're going to go over linear regression today, and Chaitanya is going to explain that to us. So can you go to the next slide? Okay, yeah. So this is our table of contents for today. We're going to start off with linear regression theory, and then we're going to explain OLS, and then we'll do some implementation afterwards.
All right, so we're gonna start off with linear regression, and this is just the basis behind what linear regression is and its history. So we're gonna start off with Francis Galton, who studied the relationships between the heights of fathers and their sons, and he discovered that people's sons were generally as tall as their father, but the children's height was also closer to the average height of everybody. And he called this phenomenon regression, based on the word regress, which means like to drift towards or to tend towards, because a son's height tended to regress towards the average height. And he also found that you can draw a line between this graph to find like the average height of everybody and predict a son's height based on their father's. So linear regression is a supervised learning model for regression tasks. It predicts target values that are numerical or continuous in nature given a set of inputs. So some applications of linear regression are stock prices, the cost of tickets, either airline tickets or just any kind of ticket, housing prices, which is what we're going to use it for today, and a company's profit estimation. So anything that involves two sets of data, like over time or a price or anything, can be predicted using linear regression. And the goal of linear regression here is to train a line of best fit on a set of data. So you can see in this data right here, there is a line, one second. There is a line of best fit going through this data. And I know it's not perfect, but it's the closest we can get over the average to predict like a different height or whatever we need. And when we calculate our regression line, we're trying to draw a line that is as close to every data set or data point as possible to reduce the loss. And we're trying to minimize the vertical distance between data points in our line. And our method for doing this is called OLS, which stands for ordinary least squares, and which I'll explain in the next slide. And the best fit line establishes the relationship between dependent and independent variables. So the method of least squares is just a mathematical equation, which gives us the error for x. So at point x, we can see that the predicted value of y is going to be the point on the line, but the observed value is going to be slightly above. So the random error is going to be the difference between the observed height and the predicted height. And to make sure that there's not a massive difference if like this point here is below the line. So to minimize that difference, we square it so that both sides are, so both of them are positive, whether or not it's above or below the line. And then there's two types of linear regression. First one is simple linear regression, which is the kind that we humans can just view and kind of guess, because it involves one feature and one target, i.e. An X and a Y line. But multiple linear regression involves multiple X's and one Y here. And that's harder to view because we humans can only see in 3D. So it means that we can only have one or two X's for this Y. But if we go any further, it's incredibly hard to graph in a way that humans can see it. And then now we're going to talk about OLS, which is the method that produces the best fit line on the data. So OLS is the statistical method that produces the one straight best fit line that minimizes the total squared error. In other words, it creates a best fit line to our data. And the goal here is to calculate a line that minimizes the distance between the predicted and observed values. So that distance is called the loss. And with all neural networks, whether or not it's linear regression, we're trying to lower the loss value. So we can calculate the loss here. Again, I showed this equation. It's basically the sum of the difference between the observed point and the predicted value. So we have the predicted value right here and then the graph on the line. So it's this distance plus this distance plus this and this and this and so on throughout the line. And OLS regression is fitted by minimizing the sum of squares of the residual. So again, the residual is the observed minus the predicted. So we're basically trying to minimize the loss here. And we square because some data points are below the line and some are above. And here's a video. I can put this in the chat in a second. And actually, yeah, I'll put this in the chat and then you guys can watch this after if you have any questions. There we go. You can watch this after class if you have any questions about OLS. And then some of the advantages of OLS regression is that it's good for inherent linear relationships. It's simple to implement and easy to view, and we can get good results with small data sets. So basically one of the advantages is that the data set can be small and we can still get a good result. And if I have like a linear relationship, such as the amount of food you eat and your weight or something, we can, or the amount you exercise in your weight, something like that, we can graph a linear regression model for that. Some of the disadvantages is that it's only limited to linear relationships, so it's oversimplified. So we can't use it for relationships that are a little more complex, like, I don't know, the amount you study and your weight might be something that you can't really graph. It's also very sensitive to outliers. So if I have a point that's all the way up here, then the graph is going to be skewed to fix that point. And then it only looks at the relationship between the average of the dependent variables and the independent variables. So it only looks at these points and the y, not anything else. And then, yeah, that's kind of it. And then this is a link about the, I'm sorry about that. And then we're going to do an implementation here in this. So if you guys want to follow along, you guys can open up this website called colab.research.google.com. I'll put the link in the chat. And then just go to this link here. And you guys should open this up, and then I'll walk you through each bit of code here. So everybody just say something in the chat when you guys have opened up this, and you should see a blank screen just like this. So you guys should see something like this, and then you guys can title it linear regression. And then once you see this here, just let me know and we'll get started. Okay, I'm just gonna assume that everybody's done. So one second. So we're gonna start here. You guys should just see a blank screen, and then what we're gonna do is we're gonna start by importing different variables and modules that we need for this lesson. So we're gonna import pandas as PD. I don't remember if you guys went through this, but this helps you work with like data frames in Excel files. We have import numpy as np. This just does a lot of like the math and like math that you need just a lot faster. We're gonna do import matplotlib.pyplot as plt. This helps you graph things, and import. This also helps you graph things, and because we want to see our graphs inside our notebook, we have to do matplotlib inline. And finally, we're going to import our data set, which we're going to do as from learn.datasets import load cost. We're going to run this. It should connect to Google servers, and once this runs, you guys should be good. So I'll give you guys a little bit of time to do that. All right. I'm going to assume that everybody's done. If you need more time, just let me know in the chat. So we're going to start by importing our data set, which is basically just a data set of Boston house prices. So we're going to do Boston is equal to load Boston, which is the function that we imported here. It gives you this information about the data set. You guys can read through this if you want, but it generally just tells you where the data set is and how you use it. And now Boston.keys. What this does is basically the Boston data set is a dictionary. And we're getting the keys for this dictionary so that we can get the keys and the values, and then there's a whole bunch of other like things we don't really need, like the description. So we're just trying to split up our data so that we can get the things that we need from it. So if we want to get the description of each of the feature names, we can do Boston.description. It's one of the keys right here. It basically tells you what each of the features or columns means. So we have criminal, CRIM, which means the criminal rate per town, and then it goes all the way down. Anything you might need to predict a housing price. And then we're going to turn our data frame into sorry about that. We're going to turn our data frame into, or our dictionary into a data frame. Oh, does somebody have a question?
Can you scroll up to the imports at the top again?
Oh,
please?
yeah, sure.
You can go back down.
All right, perfect. You have everything else in here?
I think I'm just missing after the Boston dot keys.
Oh yeah, just this. We're just getting one of the keys out of here.
Okay, thanks.
All right, and then we're gonna turn our dictionary into a data frame. We're gonna have our Boston data frame is equal to a pandas data frame with the data right here, and then the columns are going to be the feature name. So then we can see the first 5 data points in our data frame with df.head. So it prints out the first 5. And the numbers might not make sense right now. Actually, they do, but we're gonna yeah, these numbers should make sense actually. And you can see what each column means up here. Up here. So yeah. If you want, you can look through these and then I'm gonna keep going in about a minute. All right, I'm gonna say that everybody should have gotten this. If you don't, let me know. And now what we're gonna do is we're gonna look at some of our data and see if there's anything we need to fix. So first, we're gonna get information on each column. So this tells us how many values there are per column. Rather, all the not empty columns. It basically tells us the data type of each 2. So this is perfect. It tells us that there should be nothing missing. We can double check when it says up here number of instances is 506, which means that there's 506 entries in the data frame. And because each column has 506 entries, this should be good. There's nothing missing, which is perfect. Now what we can do is get we can get different values or different statistical information about each column. So we can get the average, the standard deviation, and the minimum value and the maximum value. So that's pretty cool. You guys can look through that. And then we're also going to see all of our features. And then we also need to add the target. So we're going to add a new column called house prices. And we're going to set that equal to the target. So basically the target is the house price that we're trying to predict. So we're going to add that to our data frame so that we can do some graphs involving the target. So now what we're going to do is print out all of our columns. There's no function call. Just by the way, is anybody behind here or am I good? I will take that as a no. So what we're gonna do is some visualizations. So the first thing we're gonna do is make a dist plot of the house prices. And you'll see what a dist plot looks like once we make it. Basically, just going to be a how many values or how many instances of each value there is. And then we can draw a line through these to show kind of the average. So we can see the majority of the house prices are between 20 and 30,000. And then there's very few expensive houses. Right. And then what we're also going to do is get the correlation between each column with this core function. And this just tells us the correlation between, for example, crime and house prices. So it gives us this value for the correlation. And basically, this tells us that there's a negative correlation between house prices, which means that if crime goes up, house price goes down, as you would expect. And we can also visualize this in something called a heat map. Do sns.heatmap with the correlation. And we can see that basically the darker the color is, or the closest to purple it is, there's a negative correlation, and the closest to white it is, there's a positive correlation. You can ignore this white line in the middle. Basically, it means that like house prices is positively correlating to house prices, obviously, because it's the same variable. So we can focus on this house prices column here, and it tells us that this L stat, which is the percentage of the population that lives there, this is a negative correlation. And then again, crime is a negative correlation. So generally things we would expect. And then now what we're going to do is get our X and Y. So we can, so our X is going to be everything in this data frame without the, except the house prices. So, and then our Y is just going to be the house prices. So this, just do this. This axis equals 1 means that we're focusing on the columns and not the rows. And this just splits up our data set into X and Y. Any questions so far? I'm going to take that as a no. Now what we're going to do is split up our data set into training and testing. So this gets train test split, the train test split function out of the model selection class in scikit-learn. And then we're going to split up our data set into X train, X test, Y train, Y test. Okay, so this function spits out 4 outputs, X train, X test, Y train, and Y test. And this test size function means that 40% of our data set is going to be testing. And this random state means that every time I run this, we're going to get the exact same values for xtrain, xtest because of the way the randomization function works. If we apply a random state, then it'll give us the same output for that random state. Now what we're going to do is input our linear regression model. So from sklearn linear model import regression. So this again imports the linear regression class from the sklearn library. So now we're going to make our linear model regression, and then this creates an instance of the linear regression class, and then we're going to fit it to our training data. And now that it's fit, we're going to get an output which tells us that our model has been trained. Now we can print out the intercept. So we can tell that linear regression is based on the function y is equal to mx plus b. So we can tell that the intercept is b, and this coef is m, and there's multiple because we have a different coefficient for each function or for each column that we're doing linear regression on. And then if you guys get these values or something similar, then you guys should be good to go. And finally, we're also gonna get the coefficient for each column. So we can do this with another pandas data frame, CDF is equal to as data frame. So basically what this does is it creates a column, it creates a data frame with the coefficients as the values, the columns as each thing in the value. Here, I'll just show you so you guys have an idea. So basically here's the coefficient values. We created a new column right here, which corresponds to this title. And then these x dot columns is the index down here. Any questions so far? Anybody lagging behind? Nothing? All right, again, I'll take that as a no. Now what we're gonna do is we're gonna predict we're gonna use this model that we created to predict on our X test. So I'm gonna do predictions equal to X. So our predictions are just going to be an array of a whole bunch of values for each value or for each X in X test. We're going to have a different prediction. Just going to be a massive list, but we can print it out. And we get this massive list. If you get something close to what I got, you guys should be good. It's probably not going to be the exact same, but it should be close. And then we can find our actual values. So here is the predicted value, and then here's the actual value, which is, and from this we can calculate the loss using our function right here. And we can also do is visualize y-test in the predictions. Or we can visualize how close are or the loss. So we can do SNS dot dist plot from y-test minus prediction. And then it tells us that in the majority of cases, we were right on the spot with the loss being 0. But then we can also, we did a couple that were kind of 10,000 off, and then a whole bunch more on the expensive side. So we can tell that our model is kind of skewed towards more expensive houses, but in general, it did really well. And then we can also use this metrics function from scikit-learn to figure out how wrong our model was. So we're gonna do from sklearn.metrics from sklearn import metrics. So we're gonna get this metrics class. We're gonna print the mean absolute error y-test in our. So then, oh, does somebody else have a question?
Can you scroll up to the predictions?
Right here.
Okay, thank you.
No problem. Did you get everything else below it? This is kind of the most important one we have here. As long as you got that, you should be good. All right. So we can see our mean absolute error is about 3, or actually about 4. So this tells us that our function was pretty good. And then we get mean squared error. So metrics dot mean squared error from x-test. And one of the differences between mean absolute error and mean squared error is that MSE, or mean squared error, punishes larger mistakes. So the values tend to be closer to the y-test. So we can see that this mean squared error is larger because we're squaring the difference rather than taking the absolute value. In any case, our model did pretty well. And then, yeah, so our model did pretty well as a whole. And yeah, if you guys have any questions, just let me know. I don't know what we're doing next week, but if you guys have any questions, let me know right now so I can give you some resources. And if you want any more information on this, I can share the slides or this linear regression notebook. But thank you all for coming. Is there any homework? I don't think so, right?
No, no homework for this week. And the document, which I can send in the chat, has all of the information for the slides and stuff like that. So yeah, so if you guys have any questions, go ahead and ask right now. If not, that is the end of today's class.
Where can we access the recordings of the past lessons?
So it should be coming in the document. We haven't converted it to like a YouTube link yet. But once we do that, just keep your eye on the document and then we'll update it as soon as we can.
Okay.
All right, I'm gonna get going. Thank you.
Thank you.
Bye.
Okay, then hello. We'll get started shortly when everyone starts joining. So then, yeah, you guys can chill for a bit and then we'll get started soon. Okay, we'll give people like 1 more minute or 2 more minutes and then we'll get started. Okay, we can get started. Hopefully more people join as time continues. So today is our last class. And can you guys hear me real quick? Put a thumbs up in the chat, or because I don't know, it says my microphone is different. Let me try something. Okay, can you guys hear me? Oh. Okay, I'll take it as you guys can hear me. Okay. So today's our last class and we're gonna do something different. So basically what happened the class before was that we didn't finish our code, right? So today we're gonna be starting off by finishing our code. And then after that, we'll be discussing a little bit about design processes and how we can start designing our own app. And then after that, we'll take a look at some other features of designing our app and theming and how we can use this to simplify our code. And then finally, we're going to talk about a little bit about our taking our code one step further. So let's take a look. So first, we're going to start by finishing off our previous code. So if all of you guys maybe have saved the code somewhere, or if you guys need the code, I'm going to put the starter code in the chat. And this is the code that we left off on. So remember last time I can show you what we were making, but we were playing around with layouts and we were trying to figure out how to exactly delve into creating our app and really using layouts to our advantage. So I put the starter code in chat. So that's what we worked on last time. And from there, we are going to continue to work on our code. So can you guys see my screen? Oh, you guys can't. Okay, let me share it again. Yeah, okay, this one. Okay, can you guys see this now? Perfect, okay.
Yeah.
Okay, so this is where we left off. So we started off with, remember we had a random generator for our text. and we had a random generator for our icon, and then we also created this both tab. So now when we press this, is this the solution? Oh no, this is halfway. Okay, so we randomized it and it randomly did this. But I think this is where most people were struggling, was where we got to this part where we pressed both and then we didn't really get to it. So I don't actually know what we had left, because from what our project was supposed to be like, it's very similar to what it was supposed to be like. So I'm not sure exactly what we had left, but I think I sped through the ending. So I guess we can do the ending part really quickly, and I'll explain everything really quickly. So essentially what we did last time was we took these two components, and we basically customized a random generator, and we had two random generators. So we used our array. So this is a list. Remember, we learned about data types last time. So this is our list that we used. And this list contains all the list of words that we're going to be cycling through. So some of these words, we can just keep adding to it. There's no limit to the words. We can say camera, we can say phone, where there's already phone there. We can say speaker or something like that. So we keep adding to this list, and it'll update, and it'll keep randomly generating things over here. So what we can do now is what we're going to update is we're going to be updating the state. So if you guys remember, we used a set state function to select a list of random words, right? So I think this is where most people got a little bit complicated on. So this is where most people got stuck on. So what we need to do is we need to call this selects. We created this line over here, and we called select state selected word, and we set that selected word to a list of words. So every 120 milliseconds for a total of 1,200 milliseconds, it changes the word. This gives it the animation that looks like it's generating a random image or random text in this case, but in reality, we're just cycling through these random words every 120 milliseconds. And then we also obviously had all of these animations from previous times where we just had the icon. But what I want to do now is I want to clean this up a little bit. And instead of having something like this, where there's all this leftover space, I want to bring this icon right into the middle, right? Because we have this theme of having things in the middle. So rather than having it both at one place, we're going to come up here and we're going to look at our row. So what happened during our row? So in our row, we have two widgets. So we have a text widget. So this was this part, this phone. And then over here, we have this icon widget. So this is the icon over here. And then from this, we have created an axis alignment. So do you guys remember there was two axes? So there was a cross axis and a main axis. So this was our main axis, okay? And this was our cross axis. So from this, so basically what we did over here was that we defined that the main axis had to be spaced evenly at all times. So what does this maybe look like? It's wrong because we're no longer centering it, but there's a lot of space in the middle. So if we change this main axis to center, let's take a look at what happens. Let's just try it out. Maybe something will change. Maybe it won't look like we want it to, or maybe it'll be something else, okay? Let's take a look. Oh, okay, it's all centered. And then let's take a look at the icon, but then we press both, they're right next to each other. So this doesn't look so good, but how can we change that? We can change it by simply adding another widget called a sized box. A sized box basically allows us to have space within two widgets. So this is typically used in a confined space like a row. So a row has a confined space of only the width that you provide. So this entire width of the screen that you provide, so this is our screen, this is the confined space. But whenever we have a space like a scrolling widget, that's an endless space. So we should not use a size box in that case, but rather we should use different kinds of sizers that you'll learn about later, such as containers, or maybe even different kind of paddings. So we're gonna take a look and we're gonna add the size box right here. The size box is gonna give us this width, and we're gonna provide the width of maybe 50 pixels. So now if we take a look and let's run it again. So now when we take a look over here, we can press both and look at that. There's a size box of 50 pixels right in between everything. So, but now this looks really weird. It's like offset by a little bit, right? And same thing on this side, it's not exactly in the center. So what we're gonna do is we're gonna wrap this exact same thing with a visibility widget. So what I want you guys to do you guys remember over here, I showed you guys, if you press over here, there's this keyboard shortcut. So right at the bottom left, there's a keyboard button and there's a keyboard shortcuts. And I want you guys to select this called Quick Fix. So for Mac, it would be Option and then Enter. But for Windows, I'm not exactly sure. It might be Control and Enter. So when we press Option Enter right over this widget, right over this size box, you see over here, I'm hovering over the size box. So I'm hovering over it. I have my cursor and everything selecting the size box, and I press Option Enter. And right after that, we have this drop down that shows us a lot of different options. So one of these options is Wrap with Widget. So what we want to wrap this is a similar widget. So we want to wrap it in a visibility widget because we only want this visible when both of these tabs are selected, right? So now we provide the parameter of when we want it visible. So when do we want this visible? We only want this visible when the second tab is selected. So we can say when selected tab is equal to 2, right? Because we start off from 0 and then 1 and then 2. So we only want this visible when we have the second tab selected. So now when we press run, let's take a look. And perfect. Look at that. Now it's all in the center. So if I randomly generate a text, it's still going to be in the center. And if I randomly generate an icon, it's still in the center. But when we do both, then there's that space in the middle. So these are all the things that we can look for in utilizing our row and our column. So now what I want you guys to do is I want you guys to find the perfect spot to add see right here, the random icon button is kind of merging with this other set of buttons, right? So what I want you guys to do is I want you guys to take 5 minutes and I want you guys to add a sized box in a place that'll make space right in between these two widgets. So I'm going to draw a quick diagram. I'm going to give you a quick, I guess, a quick, what is it called? A quick hack, right? So, so if you guys remember, we have a big column, okay? And then within this big column, we have a row. So we have another row. And then we have one widget. So this is a random icon. And then within this, we have another row. So, and then within this row, of course, we have many different widgets. Same thing in this one. So we have many different widgets within a row, right? So we have all these widgets within a row. But what we want to do is we want to add space right here. So we want to add a size box right here to add this space to differentiate these two things. So now when I click on this, if I click on this, right, see how there's no space between these two buttons? We want to create space between these two buttons. So I'm giving you guys a task for 5 minutes. Try to find a spot to add that size box component, okay? Try to find a spot, go back to the top, go back to the center, put things around, but remember, it always has to be within this place. So to add a vertical size box, we just want to use the height proportion, okay? So how about you guys just add this, and you guys want to copy this size box and try to add it in a variety of different places. Maybe try to add it before the container, after the container. Just try a bunch of different places and see which one works. And hopefully you guys get a correct answer. Okay. Otherwise we'll go over it. Okay. Take 5 minutes, try to solve that solution, and then we'll get back together. Okay, guys, that's the 5 minutes. So how many of you guys got it? How many of you guys could figure out to put the space between these two places? Put a thumbs up in the chat or put a thumbs up on your icon, maybe. You guys get it? Nobody? Nobody got it? Okay, that's okay. Okay, so let's take a look at what's going on here. So in this column, we have this row right here, right? So we have a row, so we can collapse this. And we see that we have a row. And then right underneath this, we have another gesture detector. So this was the container right here that says random icon, right? So this is the text that says random icon. So what we want to do is want to put a space between the row, right? Between this row that we have and between the random icon. So what I did was I came over here and I said, okay, I want to put this in the column. So I want to put this in the big column right here. And I want to put a size box of a height of 50 pixels, okay? And right now, if I run this now, if I run this, you can take a look and look at that. So now we have a size box and everything's moved up a little bit. And we can see that we have this size box that everything right here, there's that space. Yeah, we created that space by simply adding this 3 lines of code and just creating that space that makes it look a little bit nicer. See, now there's a little bit of space between everything and the icon, if you want text, you know, so it makes it look a little bit cleaner, a little bit nicer, and that's about it. Okay, so that was it for the project, continuing the project from last time. I hope you guys had fun in that project. Now we'll move on to the next set of stuff. So we're going to move on to the next presentation. Let me switch my share screen. Okay, let me show you. So next we're going to work on, so we finished this. So we finished previous code. And next we're going to learn about our design processes. Okay, so to create an app, it all starts from a design, right? So every app, it really needs to be created by either a designer or you think of a design by yourself from beforehand. And you think how we want the look and feel of the app to be. Do you want it to be minimalist? Do you want it to be very aesthetic? Do you want it to be very feature rich? And there's a lot of things that we have to do as from the designing perspective. So to create design, there are many free tools such as Figma, which allows you to create a mock-up of what the app would look like. So what we can do is we can go to websites. Let me show you. Let me share my screen again for. Okay, so we can come over here and we can type in a simple website. Oh my gosh, you can type in a simple website called Figma. So figma.com. So this is a very popular website and we can see that even I've used it before and we can create a new design file. And over here, we can create all sorts of designs and we can put all sorts of buttons, rectangles, all sorts of things over here. So if I want to create an iPhone 13 Pro, if I want to create something on there, then I could put a rectangle over here. I can maybe put another rectangle over here, or maybe a circle, right? So these are all design tools we can use to really mock up our app. So maybe if I want an app bar, right? So we talked about app bars in the very first class, right? So I want an app bar. Oh, maybe I like it like that, right? And then I can add maybe a button, like an icon or something like that, or text. I can maybe write over here, like app bar or something, right? And then we can all edit these things. So these are all part of the design process, and we can see how we can design our app in a mock-up situation. This is very important to keep in mind because it's very important to mock up and create a perfect design before you start coding. Part of this design phase is also thinking about how you're going to store and save data, right? Because we don't want to just go into design phase thinking about the UI and the user interface, but we want to also think about how we're actually going to be using and functioning the app. So there's a lot of things in Flutter that and in app development in general that we have to think about. So this is a very complicated task and very important to get right. Next, we talked a little bit about databases in the last class, but again, I just want to reiterate that UI is not the only thing that we have to do in the design process, but rather we really need to focus on getting stuff and maintaining that data in the cloud. So that's why there's a lot of different backends that we need to use, and we need to keep in mind what we need to do. So this job is basically called a code architect. And a code architect is basically someone who creates all of these designs for the actual coders. And they think about all of these little things, such as, oh, what framework goes with what backend? How would we do all of these? How would this button work? What is the functionality of this? And they think about and plan out all of these things before they give it to you in real life. And then after that, we can see how this is a very important job to actually have, as this is what people are going to be looking after and looking for, because the coders are just creating what the code architects thought of. Yeah, and that's pretty much it. If there's any other questions, I'll just stop for a sec for any questions. But other than that, we can go on otherwise to theming. So yeah, so theming. So to keep design and like keep your design constant throughout your app, you want to use the same colors, fonts, and even the sizes. You want to keep them all approximately the same. You don't really want a random huge text size and then a really small one later on, or you might not want like a lot of different fonts throughout your app. So to do this, there's something in Flutter called theming. It's a Flutter widget that allows you to set one set of code to theme your entire app. And we can pass in this value through the primary and second. So an example of this is changing the color of your app. So we can pass in primary and secondary colors, and these will be utilized throughout the app automatically by widgets who have color. So for example, if we take a look at our code, right? So we can come over here and what is it? We can take a look at our code. So over here, we have something called theme data. So we've already been using this. So theme data.dark. But we can actually just give this as theme data. And what we're going to do is we're going to change this background color. So we can change this background color with just one simple color. So what we're going to do over here is we're going to say, maybe we want to say colors.red. And then maybe we also want to change the primary color. So we want to change the primary colors to colors.orange. So I want to change those things. Primary color, maybe. Yeah, primary color. There we go. And then, so now if we run this, let's take a look. So every place I have not defined the color for, it should automatically change to, see, look, so the background changes to red. So I haven't defined the color for that. But if I take a look and I don't define the color for something like, let's say, so for our button, we've defined a color. So if I say, anyway, so basically if we don't define a color, like, so for all of these components, we've already defined colors, but don't worry about that. But if we don't define a color, then these components will automatically turn to this primary color, and the background will automatically turn as well to primary color. So an example is a text style. So if you want to apply a text style to the entire app, and to anything that doesn't have a text style, so if we want a font size, then we can apply it maybe in, say, a font size of 40, or text theme. I don't really remember. Text theme. Okay. I'm not really sure which one. So what are we going to do over here? So we're going to search up text theme Flutter. And if we come over here, we come to Flutter website. And right over here, we can see all of these different things. So what we're going to do is we're going to come over here and we're going to say, what do we want? Body text 1. So we want to change the body text 1. Let's try that. So if we want to change the body text 1, and then we can pass in a text style. And now over here, we can say font size is equal to 50. And then now if we save this, hopefully we have defined the correct text theme and text style, and then hopefully this fan, so this random text, oh, it didn't change. Okay, don't worry about it. So now what we can do over here is we can come over here and we can say text, and we can say style, and then we can say text style dot, what did we define this as? We define this as body text 1. Or text style dot of context dot body style 1. Let me check. Sorry guys, let me double check what they are saying. Yeah, oh, theme dot, sorry, it's theme, not even that. So theme dot of Okay, so now what is this called? Body text one. So we can just paste that into there and oh, it's still saying. I don't know why this is saying that. It should work, but don't worry about it for now. We'll deal with that later. So we can say another one, maybe like headline, like 4 or something like that. Still not saying it? I don't know. That's weird. Oh, what options is it giving? Okay, let's see. So here it gives us the options. Let's take a look. So text theme, and then from text theme, we want our body text one. Okay, now we're set. So now when we run this, whenever we have the style of body text one, this will automatically be implemented over here. So now if we come up here and we change the style in our theme, if we change this font size to that, or if we say color, maybe colors dot purple, right? And then now if we save this, then everything that has that text style of body text one, that'll automatically as well get changed to text and purple. So if that makes a little more sense. Okay, perfect. Okay, so that's just an example of theming. It was kind of drawn out, but it was a necessary example just to show you guys exactly how theming works. And then another thing that you can do with theming is that obviously you can pass in fonts, images, and this is really useful for like really large scale projects, right? When you want to create things that, and you want to simplify your code, because it's really important to keep your code as simple and as short as possible, because this will reduce your overall app size. And nobody really wants a really big app on your phone because then you're taking up unnecessary space. So you're really trying to reduce that size and try to make everything as nice as possible. Okay, how can we take our code one step further? So as you guys know, for the past 3 weeks, I've provided you guys with starter code, but rather than that, we need to start making our own apps, right? So we need to start thinking of our own apps and really need to start thinking of how we can develop and design our own apps. So first, the initial step obviously would be thinking of an app idea. So this app idea is extremely crucial because I want you guys to think of something that's not too complicated, maybe something that doesn't have to do with database, maybe cloud databases, but maybe we can think of something that just does local databases. And then with this, we can create our own app by downloading the Flutter projects, downloading Flutter on our device itself. So rather than using this Flutter on this website, I would recommend you guys go to flutter.dev. And over here, they have a great place just called Getting Started. So get started over here. Here are the operating systems. So if I click on Mac OS, it tells me all the things I need to do to download Flutter and everything I need to do to set it up. And with this, I can set up my perfect app, and I can set this up, and it tells you all the steps. So what I want you guys to do is I want you guys to visit flutter.dev. And here I can put this link in the chat. Oopsies. Put this link in the chat. If my bar would go away. Okay. Yeah, so I can put this link in the chat, and I want you guys to check out how to download Flutter and really utilize the full capabilities of Flutter, right? And then after that, once you've fully downloaded Flutter, and you also need an IDE. So my recommended IDE would be Android Studio, as Android Studio has a built-in Android emulator. So an Android emulator is necessary to test your apps on your computer. So, and what is an Android emulator? It's basically just like an Android phone on your computer. And what this does is it lets developers like you guys, now new developers, it lets you guys test these apps on your phone. And unfortunately, iOS is only limited to, you can develop, so the beauty of Flutter is that you can develop iOS projects on your Windows laptop, but you unfortunately won't be able to release it on iOS until you get a Mac, because a Mac is necessary to release this iOS project. So that's just the unfortunate part about Android Studio. I mean, about Apple, I guess. Apple doesn't let you release stuff from Windows laptops. But don't worry, you guys can release to Play Store still, and that's a great experience as well. So now next, I would recommend you guys to check out starter projects from YouTube and throughout the web. So if I go over to flutter.dev, so I would recommend going to this website. So I can put this in the chat as well. So this is the Code Labs website for Flutter. And this shows all the places where you can really get started with your first Flutter app. So some really easy ones to get started with is obviously this workshop by Flutter. And this is great to get started with and really understanding how to build apps yourself, understanding the framework, understanding what the logic is behind Flutter, and really building up your experience. This is very vital and very useful for new beginners, especially just like you guys who have had these hands-on sessions, but it's more like guided hands-on sessions. So these will be less guided, and these will really help you guys develop your need and your skill and your hopefully your passion for app and web development, as I'm passionate about it now. So I don't think I have much else to say, but if you guys have any questions, feel free to let me know. So let's see. So even over here, you can check out that you can get the Flutter SDK on Chrome, and you can even run it on, you can try to figure stuff out through there. I've never actually ran this before, but it looks pretty cool. It's probably a new feature. But that's pretty much it. So if you guys have any questions, you guys can feel free to shout it out or text it in the chat. Okay, it doesn't look like there's any questions. So what I want to do now is I want to, since we have a lot of time left over, let's say 25 minutes left over, what we're going to do now is we are going to create our own Flutter project from scratch. Okay, so what I want you guys to do is I want you guys to load up a new Dartpad. So go to dartpad.dev. It's going to be a whole new thing. And I want you guys to click up here. So let me share my screen again. So if I come over here, what I want you guys to click is new pad. So I went to dartpad.dev and I want to click new pad up here. Okay. So open up a new tab. Okay, guys, remember to open up a new tab. Otherwise your old tab won't save. So here's my old tab and here's my new tab. Okay. So remember to create a new tab and then we want to create a new Flutter tab. So this automatically starts us off with like a little bit of Flutter, a little bit of a Flutter project. So if we run this right now, it's just going to be I think it just says hello world and it just has a theming, right? So we use this headline, this text theme earlier. So next what we're going to do is I want you guys to think of something interesting that you guys want to build, and maybe something really simple, like maybe even a, maybe you guys could build a counter app like we built it in the beginning, but I want you guys to build this by yourself. So I want you guys to think of the different types of components. I want you guys to think of stateful and stateless, right? So if you want to convert to a stateful widget, we just hover over it and remember to use the action button and convert to stateful, right? So that's one way we can convert to a stateful widget, or we can create our own stateful widget. But what I want you guys to do is think of something that's very unique, very interesting, and I want you guys to create a really simple thing, like maybe even a counter app is a great way to start off and develop it by yourself. So what I want you guys to do over here is I want you guys to replace all this code with something called a scaffold, which is going to be our back end, our main display. Okay. And then over here, we're going to say our body is going to be a column, right? So we worked with columns, and we're going to add a property of children. Remember, this is a list of widgets. And if we want to get rid of this preferred constant, I'm just going to copy this real quick. So don't worry about these like warnings. These warnings are just linter warnings. So they're not too important or useful in my opinion. But yeah. And so now what I want you guys to do is over here, I want you guys to create a simple text widget with one button underneath it. So that's your job for right now. So I want you to create a simple text widget that says a counter, right? So it'll be like a counter, like maybe a number or a variable. When we talk about how we can have a variable. So I want you guys to create that, and I want to see how you guys do it. So go ahead. So the last like 15 minutes left of 25 minutes left of class is going to be yours. I want you guys to create this, and I'm here to help. So if you guys have run into any problems, any bugs, anything, then just share your screen and we'll work through them. I'll also be working on it. So I'm gonna stop sharing my screen so I don't give away the answers. So I want you guys to work through this by yourself and try to figure out exactly how we can make a simple counter app, right? It's just gonna be a counter that counts from 1 to 100, maybe. We don't even need a reset button. We just want a counter, right? So think of all the components that are needed. Oh yeah, Arhan, sorry, I didn't see your hand. Do you have a question?
Yeah. So I made the counter, but it's kind of stuck in the upper left corner, and I don't really know how to move it.
Okay, good question. I had the same thing. So what we're gonna use is, do you remember the there's axes, right? So there are the two axes. Let me draw it out real quick. So
Oh, you're not
um,
sharing the screen.
yeah, I'm gonna draw it real quick. Okay, so over here we have, let me start over. So we have our screen. So we have our screen here. And then basically what you're trying to say is that, oh, I have my stuff in this one corner up here, right? So what we're gonna do is that I'm assuming that you have a column. So we're gonna start off and we're gonna draw the two axes. So there's gonna be a main axis and there's gonna be a cross axis. So in this case, what we're gonna define is we're gonna define these two properties and we want it in the center. So what we're going to do is we're going to say, okay, so we want the cross axes and the main axes to be in the center. So we're going to say, we're going to give it the properties of main axes. Remember the main axis dot center. So it's, let me just type it out. It's main axis alignment. And then we provide a main axis alignment dot center. And same thing with the cross axis, right? So we want to do the same thing, cross axis alignment, and then cross axis alignment dot center. If that makes sense. Does it make a bit more sense?
I think I tried doing that, but it only moved it to the center on the cross axis, and not
Just
on,
moved it to the center up here
no, on the other one.
on the other one. So it just moved it over here, right?
Yeah.
Okay, so what you want to try now is, do you remember the quick actions? So like the on Mac, it's option return.
Oh,
Yeah, so go over the column. So go onto column. So go onto your column widget and then wrap that widget with a center widget. So there'll be an option. So when you press option return or control return, it'll say, oh, wrap in, and then there'll be like different widgets that you can wrap in. So I can show you really quick if you didn't get it.
I think I got it.
You got it? Okay, perfect. Okay. Yeah, that's exactly what we want to do. So we want to just move it and it's all just about the layouts that we're going to be using. Yeah, perfect. Okay, good job. Anyone else? We have like 5 minutes left in class. Does anybody want to share their project? Arhan, do you want to share yours since looks like you're done?
I actually have to do it, but I got what you're saying. So
Sorry?
I got what you're saying, so I have to do it.
Oh, okay, got it. Okay. Yeah, after you're done, you can share your screen if you like. Anybody else would like to share their project while we're waiting? You can just click on the share button, and don't worry, even if you're not even done with your project, don't worry. We can at least take a look at it and we can see how it works.
So I tried putting it in a column, but it says then so I put like child column.
Yeah, or in the center widget, right?
In the body. Oh wait.
Don't worry. How about you share your screen? We can take a look at it.
Okay.
Okay, yeah.
Oh, I need 118.
Okay, so now what you want to do, so remember we did like the main axes and the cross axes. So we want to do is we want to define what we want to define is we want to define the main axes and we want to put it as a center, right? So not over there, right? So it's just a property in the column. So in column, right above children, yep, just press enter, yep, and then define main axes. Yep, main axis alignment, and then give it the alignment of center. Perfect. And remember to put a comma afterwards. There we go. Perfect. Okay. And let's press run. Let's take a look. Hey, nice. Good stuff. Okay, let's see. Does it work? Nice. Good job. Good job. Good job. You did a really complicated counter. So that's really nice. Good job. Does anybody else have their counter that they want to show? Okay, otherwise, I think that's about it for these classes. I'll send out a couple more messages on our Google Classroom, and then other than that, I think I'll see you guys whenever. Maybe you guys will see me around. But it was nice knowing you guys, and I hope you guys learned something and had fun. But that's about it. So bye, guys.
Bye.
I'm gonna give the participants a few more minutes to join, and I'll start in a couple of minutes. Okay, I'm going to start. I think people are probably on vacation, so I'm going to present and hopefully people can see this the recording at the YouTube link. So this is the 4th week of the boot camp, and today we're going to be covering basic robot software. So just like basic blocks and general like basic information you need to code your FLL robot using the EV3 software. So last week we had talked a bit about sorting your missions based on where they're located on the mat. So dividing them into different zones as it shows on the picture on the slide. So like in this picture, the team has chosen to divide the mat into 3 different zones. And in each zone, the robot would complete all the missions in that zone. And that would just take 1 trip for each zone. And by the way, like a trip would be defined as like leaving the robot base, and coming back. So just 1 trip for each zone. And between going to each zone, the team can remove attachments and replace attachments based on which missions they need to complete. And this, to just reiterate what we had talked about when we had talked about robot strategy, this would decrease the amount of travel time and allow you to complete more missions in the allotted time. So you want to make sure that you can complete everything quickly. So here are main actions used in missions. It would be push, pull, grab, and rotate. And then another one would be like dropping any objects. And these actions should be considered when you're designing attachments or like deciding what attachments need to be used for each mission you're completing. And you should group your missions and create your zones based on which attachments you're using and what you can accomplish with each attachment. So for instance, if one zone on the mat requires a lot of pushing or dropping or picking objects up, you can group those missions together so that you can use the same attachment for the multiple missions. So this is just like a screen grab of the Lego website. If you go to the slideshow that's linked in the Google Doc, in the speaker notes, I've linked this website so that you can see these videos and just like all the information given fully. But yeah, the website just kind of gives basic information you'll need to make programs or coding your robot, things like that. There are a few videos and they're pretty long, like about 45 minutes, but they're very informative and you can always skip around in videos to get the information that you need. So we're gonna start talking about the different types of blocks. So this is the first category, which is action blocks, and these are like the most basic blocks that you need to make your robot function. Especially the top 4 blocks. These like mainly control like all of the movement for your robot. So the first block shown controls a medium motor. The second block shown controls a large motor. The third block controls steering. Fourth block controls the tank. The fifth block controls the display of your brick. The sixth block controls sound that your robot might make. And then this last block controls brick lights. So I'll show like a video at the end of today's session that'll just kind of show how you can use these blocks and use them to code your robot. So this is the second category. These are flow blocks. And as you can see, it says the flow blocks control the flow of the program. So the first block controls or just kind of starts your program, the green arrow. So all the blocks you attach to this, they would run after your program has begun. The second block is used to make your robot wait for a certain amount of time. You can control, there's like a little empty square. If you click on that while you're coding, you can control how long it waits. The third block is a loop block. So again, like all of the squares underneath, you can adjust like the values. So the loop block would loop the code as many times as you want. The fourth block is a switch block, and this basically means that it will run, it's like divided up. So these are two cases, and your robot will run the case depending on any sensor values or any just like situations. And then the last block is a loop interrupt block, and this stops loops earlier than it's supposed to based on, whatever you put in this empty square. And again, if you go to the slideshow, I've linked a few helpful links to help you learn more about these blocks and how to code them up. These are sensor blocks, and these will be really helpful when you're trying to code up any sensors you might attach to your robot. So the first block is used to sense any buttons on your EV3 being pressed or clicked or anything. The second block is used to program the color sensor, and the color sensor basically detects any color that's placed in front of it. So this is really helpful if you want your robot to follow the black lines that are on your mat. The third block is used to program the infrared sensor. The fourth block is used to control the motion rotation sensor. The fifth block is used to control, is used to measure, compare, or like reset time, or any timers used in your program. And then the last block is used to control a touch sensor, and this would be like if your robot comes in contact with an object, then you can, if your robot does that, then you can code up like certain cases in case that happens. And again, you can find information or more in-depth information about these blocks by searching it up on the LEGO website or looking at YouTube videos if you want to learn about these blocks and how to use them. So these are some of the more advanced blocks. They're not completely necessary to code up your basic robots, so we're not going to go too much in depth with them. But the first section of blocks shown with the like the red blocks shown on the left side of the screen, these are called data blocks, and the second section is called advanced blocks. And again, yeah, so if you just want to learn more about these blocks, you can research them on Google or YouTube videos if you're planning on using any of these, or if you want your robot to do anything that these blocks function or these blocks control. And then the last section is called My Blocks, and this basically allows you to create your own blocks that you can use in your program. You can also kind of, to learn how to use these, you can also Google it or YouTube. I've linked a few helpful articles and YouTube videos in the speaker notes if you want to take a look at those, if you plan on using these blocks. But yeah, but these are like, again, the last three sections, the red, dark blue, and the teal, they are a lot more advanced than you need for your basic robot. And, so I'm gonna show like a quick video. This is one that is on the Lego website, but this is just kind of a quick video to show you how to create a basic program and upload it to your EV3 brick.
Hello and welcome to this tutorial. My name is Lasse. I'm part of the LEGO Mindstorms team. Today, I'm going to be showing you how to make your first program. For this, we'll need the LEGO Mindstorms EV3 programmable brick. We also call this the P-brick. We'll need a USB cable, and we'll need a computer with the LEGO Mindstorms EV3 Home Edition software installed. So let's get started. This is the start screen of the software. We also call this the lobby. This is where you get access to building and programming instructions for the robots. In this tutorial, we're going to focus on programming. So we're going to create a new project. To do this, you click the tab up here. This will open up the programming interface in the software, and that's what you see here. In the center, we have the programming canvas. This is where you build your program. To build a program, you need blocks. And the blocks you can find down here in the bottom. We call this the palette. And we have different categories of blocks down here. I'll describe some of these in more details in the later tutorials. On the right side, you can see the hardware page. This is where you can get details on the P-brick that you've connected. So when I'm going to connect the EV3 later, I'm going to show you a bit more down here. Up here in the corner, we have what's called the content editor. This is where you can document your work. We're going to close that for now and focus on programming. So up here, we have different tabs. On the upper tab, you can select between different projects, and inside the project we have another set of tabs, and this is where you can have your different programs. We're going to stick with one program, but first I want to give this program a name. So I'm going to double click this, and I'm going to call it My First Program and hit enter. Now a good thing is also to always save your projects. So I'm going to do this now. I'm going to save this as My First Project. Now we're ready to connect the P-brick. We're going to do this with the USB cable. So we're going to take the USB cable and plug it into the computer, and we're going to take the other end and plug it into the P-brick. Now you can see here in the hardware page, it's going to show the details about the P-brick that I've connected. To see that it's connected, you can see the red icon here that says EV3, and that shows you if you're connected or not. Let's build a program for the P-brick. So I'm going to make a small program that is just going to make the EV3 say a sound. To do this, I'll select the sound block down here. So I'm going to drag this up and place it behind the start block. Our start block is where your program starts. To select which sound I want to play, I press the white field up here on the block, and I'm gonna go into the Lego sound files to select the sound, and I gotta find a good sound down here under expressions, and let's do the fanfare. So that was the software playing a preview of it. Now we're ready to download this program that we've built to the P-brick. To download it, we need to go down to the hardware page and press this download icon. When I press this, it's going to transfer this program down to the P-brick. Like that. The sound you heard tells you that the program was downloaded. So if we go to the P-brick to run the program, we need to go to the second tab, which is our projects. And here you can see the project that we named My First Project. And then we open that up by pressing enter. And you can see that My First Program is in here. So we go down to that and press enter to run it. So that's how you create your first program.
So you can always rewatch this video if you decide to look back at the slides. It's in the video he had mentioned that you can also make notes on your code. It's really helpful to do so because we'll talk about judging next week during our final week of the sessions, but judges for the robot design section, they really like to see you understand how your code works and like why you added certain features to it. But also make sure that you save your code like every time you make an adjustment and every time your robot works, because you don't want it to accidentally get lost if something goes wrong. So yeah, so this was just like a really quick video on how to create your first program. And today's session was kind of short. It was just kind of showing the basics of coding. So we're going to stop here. Next week is the final week of the boot camp. So we're just going to be going over less robot building and design aspects and more on like the actual competition, like judging categories and core values, because these are all equally important to your robot design and how well your robot works. Are there any questions I can answer before ending the meeting? Okay. So yeah, so you can just email me if anyone has any questions before next week. But other than that, I'll see everyone for week 5 next week. Bye.